Hi everybody, and welcome back to physics. Welcome back. We're going to be looking at a new chapter this week, chapter 27. Okay. Today's topic, this video's topic, is blackbody radiation, whatever that is. And this comes from section, let's see, I believe 27.1. So, 27. Was this going to fit? Yes, it'll fit. 27.1. Okay, there we have it. Now, what I want you to do here, well, this chapter, I don't have the title of it up here, but this chapter is has a interesting title: Quantum Physics. Okay, so what you need to know now, before we get into it, is that this basically means physics of little bitty things. Molecules and smaller, pretty much. Even large molecules and smaller. We'll be looking mostly at atomic and nuclear situations, but both atomic and nuclear physics fall under this heading of quantum physics. So for now, we'll say what the word quantum means later on, and we'll fill that out. But for now, I want you to think, when you hear quantum, just think real small. Okay? That being said, we're going to start with light, because the way light interacts with really small things has a lot to do with the way the world looks around us. So we're going to start with light. And I want you to start with an image in mind. You are in your kitchen, okay? And in your kitchen, you have an electric eye of a range, an electric range. And so you have, the little coiled up piece of metal that when you turn it on, it heats up and makes your water boil for pasta or whatever. Okay, so this is the eye of your stove, but I want you to think about something else. So you're in your kitchen, standing in front of your electric stove with the electric eye there, but the lights are off and you can't see anything, including the eye of your range, the electric eye. You can't see it. Now, turns out the temperature of that eye is about 300. This is looks a little weak. 300 kelvins or so. That's room temperature. Now it turns out that even at room temperature, an object, and we're talking now about the eye of your stove, could be any object at 300 kelvins, whether it's the door or the floor or whatever. All objects at 300 kelvins actually do produce light or radiation. When I say radiation and light, okay, same thing really. Although we typically think of the word light as radiation we can see, scientists call it all light. But the point is that your electric eye does produce light at room temperature, even when it's off. You can't see it, right? You're in the dark. The eye is right in front of you, but you can't see it, okay? Because the light that it is producing is mostly, how do I have it? Yes, I've got it written this way here. Infrared. So the light is real. It's perfectly, totally real. It's just that our eyes can't detect it. Okay? Now say we turn it on. Oh, actually, what I'll do is over here, I'll make a plot of, is that going to fit? That's going to fit. Of frequency, actually intensity on the y-axis. And for our money, when you hear intensity, just think brightness. Okay. Intensity versus frequency. So as you go from left to right along the x-axis here, the frequency of the light increases. right here around the middle somewhere are the boundary lines. Well, I'm not going to be able to fit it in there. The light spectrum, the rainbow, right? Red is a lower frequency than purple. So in this frequency range here is all the light that we can see. So this is visible. This would be infrared. This would be UV, and so forth as you go out to the gamma rays and down to the radio waves. The whole spectrum, the whole electromagnetic spectrum is stretched out along the F-axis here. You know, I could go on to X-rays and gamma rays up top. I could go down to microwaves and radio waves down closer to the origin, but you get the idea. Okay. Turns out that all the light that's put out by this particular eye, when it's at 300 kelvins, it's all down here. It's in the infrared. We can't see it. There is no light produced by your eye. Remember, it's off. Okay, it's off. There's no light produced by that eye that we can see. It's all down here in the infrared. Okay, and I want you to make note of one particular value of frequency. That's the peak amount of frequency. The peak amount of light right there occurs at a value we call F sub m for F max. Okay, so that is the F m is F max. I just wrote it FM on the graph here because it's so small I couldn't have put max down there. And so that tells you the frequency at which the maximum amount of light is produced at that temperature. We haven't even changed the temperature yet. Okay, we have not changed the temperature. It's still off. And all the light it produces at 300 kelvins lives down here in the infrared part of the range, yet there is a maximum frequency, a frequency of maximum emission is actually what it's called. The frequency of maximum emission, the frequency at which this light is brightest. Again, we can't see it. At which this radiation is the most intense. So if we collected all of that infrared light coming out of that eye at 300 kelvins and picked it wave by wave, separated out all the light waves that are being produced, some of them would be down here, some of them would be up here, but most of them would be right in the middle somewhere, kind of like a bell curve. You know, you're sampling a bunch of exams, most people make some average amount in the middle. Then there's some people who do super well at the high end, some people who do poorly down at the low end. The point is that the light that's leaving this eye doesn't have all the same frequency. It's got a range of frequencies. But there's one frequency that is the most common, okay, that is at which it is the brightest and it has the most intensity, and that is F max. Okay, at the top of the peak, that's where F max is, or what I call it F sub m here. Again, I just called it F sub m. The book calls it F max. That's what it's really called. I just wrote F sub m here so it would fit in the picture. Okay. So what we're going to do in the next video is turn up the temperature and see what happens to the curve. Okay. So I'll stop now and we'll pick this up next video.